Now we're going to develop a formula for the sum of the interior angles of a polygon. So we're going to look back at what we did previously, where we had the polygons and the number of sides and the number of diagonals from one vertex. But now we're going to look at something else, which is the number of triangles that we create with those diagonals. So in the triangle, I have no extra diagonals from the vertex, and I just have one triangle. We all know that a triangle has 180 degrees, at least in Euclidean geometry. For the quadrilateral, I'm able to create one diagonal from a vertex. How many triangles does that create? That creates 2. And we know the total number of degrees is 360 degrees. So I'm looking, is there a relationship? Here when I had 1, I had 180. When I have 2, I have 360. For this pentagon, we're going to create 2 diagonals from the vertex, which gives us 3 triangles. I will tell you now that a pentagon has 540 degrees. So 1 to 180, 2 to 360, 3 to 540. What about a hexagon? Well, there are 4 triangles there, and it has 720 degrees. So you're noticing the number of triangles is related to both the number of diagonals and the number of sides. It's just the number of sides minus 2. It's one more than the other when we had the diagonals. And maybe you notice that if I multiply each of these numbers here by 180, that gives me the number of degrees. So I go 180 times n minus 2. So by inductive reasoning, we get the polygon angle sum theorem, which says the sum of the interior angle measures of a polygon with n sides is 180 times n minus 2. So now we're going to go ahead and use this formula to find the degrees in a given polygon. In this example, we're going to look at a 29gon, so it has 29 sides, and n is 2. So we'll use the formula sum of angles equals 180 times n minus 2. So in this case, n is 29, and I substitute, and I get 180 times 27, or 4,860 degrees. So finding the sum of angles in a polygon is actually pretty simple. It's just using the formula. Taking 180 times n minus 2, or basically the number of triangles you can create in the polygon from one vertex. Now we're going to do a twist on it. I'm going to give you the total number of degrees, and we're going to figure out the number of sides. You still use the same formula, but the left side is even more important now because I need a place to put this 5,220 degrees. So it goes on the left. Now I can divide both sides by 180 to make these numbers a little more manageable, and I get 29 equals n minus 2. Add 2 to both sides, and I get 31. That means this polygon has 31 sides, or it's a 31gon. So for further reflection, what shape did we use to develop the formula for the sum of angles in a polygon? And could I have a polygon with 3,000 degrees? Why or why not?